Yes, ma'am.
Good. So Vinu is set to join. Vinu has joined, right? E 2 pi RH will be equal to Q by epsilon naught. So that is nothing but E will be equal to, we need electric field intensity. That is our motto, right? Q by 2 pi RH epsilon naught. There are no. But what is Q, ma? It is nothing but what? It is H. Then what is the lambda value? Sorry. This length we have considered. Okay, so that is H. For H length, what is the charge enclosed lambda H? Clear or no? So I am going to substitute this. Instead of Q, I will write lambda H divided by 2 pi RH epsilon naught. HH will cancel out. So it is lambda by 2 pi R epsilon naught. Remember, if you don't understand this unit length charge, simply you can write lambda equal to Q by L. What is Q? Q is lambda L. Right? Where length L is the length of the given material. So here what height and length I have taken, H is the height length I have taken. So the charge enclosed will be lambda H. Is that clear, Vinu? Ishan?
Yes, ma'am.
So what you can do, multiply and divide by 2. Okay? So 2 means 4 pi epsilon naught R. Right? So this one you can write it as 2k lambda by R. It is easy, right? Substitute the value of k and do the numerator. Clear? Now from this equation, since all other things are from this equation, we can say that E is inversely proportional to the distance. Because lambda is constant, epsilon naught is constant. For the given cylinder, the radius is constant. When everything is constant, the electric field intensity is inversely proportional to the distance. So what is the graph? This graph only people tend to ignore. It's very simple. From the equation you should know it is inverse relation, rectangular hyperbola. That's all. Electric field along y-axis or along x-axis, then it will be this way. Is it clear? And I know Vinu is very fond of vector form, right? So in vector form, what is the value? How will you represent it? E vector. And what is the vector quantity present? Lambda is a scalar quantity, charge per unit length. 4 pi epsilon naught is constant, right? So let me take this one. 2 is not necessary. The original equation I will consider. 2 pi epsilon. What is the variable quantity here? The position vector. R will contribute the direction. So what it is? Unit vector. So what I have done, simply I will tell you, okay? So first we have to fix what is Q by epsilon naught. RH epsilon naught. L and scale don't. Here my everyone. Infinitely charged potential. This is very simple. Compared to that, now you know it very clearly. 4 steps. Within that we will do that. Again, what you have to do, consideration is very important. Without that, what will you say? So consider a plane sheet, okay? Consider a charged plane sheet of uniform charge. This is keyword. Non-uniform, we are not measuring. Uniform charge distribution of density. What is that value? Sigma. Sigma is given by what? 2 by A. Right? Now I am taking positive. So you want to leave, right? this vertical surface which can pass through this. Okay. And that side also, it is a closed surface, so cylinder can pass through it. Here, my diagram is not right. Okay, better. So now we are consider a Gaussian surface, Gaussian cylindrical surface of cross-sectional area A. Directly I am considering the area. Okay, cross-sectional area means what? This area is A. Okay, so I have taken. So what is the electric field direction? You know that. Just now we discussed the electric field will be always along in this way, right? For this given figure, electric field can be either this way or that way because it is a sheet where the positive charges are present. So due to this, electric field will be there on both the sides. So now what is the area vector for this one? Now I can split it into 1, 2 and 3. Okay, so for the third surface, it will be area vector is in this way. And for the first one, area vector is along left side. And for the center one, what is the area vector? Anywhere you take any element, this will be this. What is the angle between these vectors? Here it is 90 degree, here it is 0 degree. Correct? Area vector and electric field along the same direction. Here also it is theta is 0 degree. Remember theta is 0 this side also because electric field, what did I say? Plus Q means this way also it can go this way, like a sunflower, all this way. It will be. So the electric field will be in this way. Now, what is the net electric flux? You know from the Gauss'law net electric flux is given by what? Phi net will be nothing but phi1 plus phi2 plus phi3. In phi1, what is that value, ma? It is E dot ds. What is this value? Cos 0, right? And phi2 is what? E ds dot you don't use when you use cos. Cos 90 plus E ds cos 0. Here I forgot to put the integration symbol. This is 1, 2, 3. Now what is the value? Tell me. Phi net will be equal to integration cos 0 is 1. So it is nothing but E ds plus here also it is 0. Second surface it will be 0 because 90 degree. Third surface it is E ds only. So just integrate or you can write 2E ds also. 2 times it is there. So what it is, ma? If you don't want 2 times, you just do it here only. Not an issue. E is constant, so integration of area. E is constant here also, the integration of area. What is this value? E dot es. Here no dot. Okay, here also integration of dx is x. If you remember and you write simply es, no dot symbol. So phi net is given by what? 2 times es. But what is the area of cross section we have taken? That is A. So 2EA. Since S equal to A. Area of cross section I have taken here as A. So 2EA. From Gauss'law, what we know? Phi net is given by integration. Sorry, not integration. Already we have done it, right? Now from Gauss'law, Q by epsilon naught. Where Q is nothing but what? Sigma by A. So sigma can be. Sorry. We know that sigma equal to Q by A. So Q is nothing but what? Sigma A. So you can write where Q equal to sigma by sigma A. Clear or no? So this is equation number 2. From 1 and 2, what you can write? Sigma A by epsilon naught will be equal to 2EA. AA cancels. Electric field is given by sigma by 2 epsilon naught. This is very, very important. Even in capacitor, we will use this. Just let me know whether you have understood this or not, because this sigma is constant for a given charge distribution. Epsilon naught is also a constant. So the electric field intensity due to a plane charged sheet is what? A plane sheet of uniform charge distribution is constant everywhere. E does not change its value because there is no R present in the equation. It shows that electric field is constant. The first point. The second point in this is it clear or no? The graph, since it is a constant, if you draw a graph between area vector and the electric field intensity, what you will get, ma'am? You will get, it is independent. So always this electric field value will remain constant. So parallel line, this is a line parallel to x-axis, you will get, what is that value? Sigma by 2 epsilon. Is that clear, Ishan? Is that clear, ma'am?
Yes, ma'am.
And how the electric field will be? That is, this is negative charge, so it will be inward. Clear or no? Okay. It is inward to the plane sheet. Inward to the sheet, and here outward. Next point is very simple point. Okay, instead of thin sheet, this is thin sheet I have taken. If you have taken a thick sheet, then both the surfaces will have separate charges. In this phase, you will have one charge, and the opposite phase, you will have another. So what will happen? Here the charge distribution will be there, and back side one charge distribution will be there, which I am representing with P. Okay. So what is the net electric field at any point due to this? If this is the E1, if I take, what is the direction of E2, ma? E2 will also be in this way. Yes or no? Is it clear? And similarly, here also, this if you take it as E2, then E1 will be, due to this red color also, it will be this way. Right or no? At any point, if you take the net electric field, it is given by the superposition principle. What will happen? The electric field will be equal to sum of these two. What is E1? Already we have seen sheet, sigma by 2 epsilon naught. And due to the next sheet, you can consider it as a 2 sheets. What is the net electric field? Sigma by epsilon naught. Is it clear or no? At the last one, it cannot be uniform. Okay, that is what will happen. It will bend or something. This can go in this way because for this charge there will not be any cancelling element, right? The last charge, right or no? So that's why, because of that, there will be some edge effect. So that edge effect, if you want to avoid, luckily you don't have that kind of derivation now.